G'day guys, welcome back. Been a bit of a delay. I've had some serious headaches with supply chain and other things, so apologies on that. As you can see, I've got the water cooler that I'm thinking I'm going to use on the bike. I tried to get a tiny motorbike radiator. Turns out that the profile was way too thick and also just generally not as compact, so I've opted for a computer water cooler. The only problem with it is that the fin and tube relationship is really fine, so I'm a little bit concerned that it might get blocked up with dust and stuff, so I'm going to do a little bit of testing on that in the next little while to see how that goes. Great thing is that these fans by Nocta are IP67, which is crazy for a computer fan, but turns out that yeah, they're completely waterproof, which is really interesting. So they'll be okay. This is a really good size for what I need. So you can see over here we're fast running out of space on the bike. So probably since last time my AC 3.5 kilowatt chargers arrived, I'm planning on having that on board, and you can see that this foam stuff is now my best friend. I've just chucked in my two main contactors there to see whether they'll fit, and you can see down underneath here, tucked in, over here is the water pump, so that's just a 3D print I've slotted in there to see whether that will fit, and it's pretty hard to see, but it looks like it can just squeeze in there, so that's nice. But yeah, I'm running out of space, which is not surprising, but also not ideal. So yeah, the onboard charger is taking up quite a lot of room in the remaining space that I've got in the chassis. So ideally, you see this bit of wire here kind of replicates the tube that's going to sit here, that is going to support the seat, but also makes up a big chunk of the chassis that we're going to bring around. So ideally, you know, most of this equipment will sit down in below there and fit. Charger being one of them, and also there really isn't space sort of anywhere else. You know, you can see down in here, that's where we're going to put the BMS inside the battery box, so that's kind of taken, motor's taken. Up on top of here is my safety glasses packet is, you can see that's where I want to put the motor controller and also DC-DC converter. So I got one of those, which is a pretty expensive unit from China, but it's way too big. The form factor's twice what they said on the specification, so that was a waste of a ton of money. So I've actually got a smaller firm here in Australia to manufacture one that can sit across the back here underneath the motor controller. So I'm going to put the whole lot on a chill plate, motor controller and charger, and hopefully it all fits in there. It's going to be really tight. Done some basic dimensional mock-ups with my favorite foam, and yeah, it'll be touch and go. So fingers crossed. Really isn't any room down on the front here, as far as the you know, maybe hanging it off the front, down in front of the battery pack. I sort of had thought of that, but you can see that, you know, it's sort of way too big. So that might be an option later, maybe, if I get into a real huge amount of trouble with form factor. So as far as location's concerned, we're gonna go in here. So I know that that's sort of jammed up against the cooler at the moment, but that's sort of a mock-up of roughly where it'll sit. So we'll obviously have a little bit of breathing space, you know, up in here, and I'll angle this up at a bit of an angle as well, so the airflow moves through. Yeah, these fans are suck through, so probably go around the other way as far as the exact location, or I'll put the fans, these fans on the other side. And it's really great because this computer cooler actually has fan mounts for both sides, which is really handy. That's going to let me then mount this cooler in a on the other side. I'll create it like a custom bracket to hold it all nice and solid. They're really neat the way they're set up. They've got a little partition here and allows you supply and discharge. So I've done some rough calculations. This is good for about 4.5 kilowatt at the ambient temperatures that I'm looking at. So based on the motor controller and the motor's efficiency curves, when they're running at their least efficient, they'll be about 4.5 kilowatts so of heat rejection. So I'm hoping we're about balanced as far as heat in and heat rejection capability of the radiator. It's not really an ideal location. I would have loved to have been able to scoop air up from the front. What I'm hoping to do is get some vents in a side cowl here to force air in behind here when I've got a little gap underneath there, and let the air work its way up through. And obviously these fans will be on the other side, so they'll be able to discharge out either side. Got the mudguard in here mocked up to just allow clearances for the back wheel. Also, I'm considering leaving some kind of mudguard on the bike as well, just to stop this filling up with shit in the back here and lumps of stuff getting in the fan and whatnot. I'll put a grill and stuff in there, but it's pretty cool. I'm pretty excited that I can get a charger on board. So that means I can set this up. This will go into any standard charger, not fast DC, but just regular AC charger. So any EV station should take this. It's also compatible with CHAdeMO. Now I know CHAdeMO is being phased out globally in favor of CCS2. But you know, if I wanted to go down the road and do CHAdeMO, I could. There's still a fair few CHAdeMO chargers here in Australia, which is kind of nice. So I could go fast CHAdeMO DC charging. So that means I could fill my pack up in about half an hour from empty to full. But I'm not going down that road. I'm just going to go standard good old-fashioned AC charging. That lets me flexibility with on charging stations, or just on a good old-fashioned 10 amp or 15 amp outlet anywhere in a park, or when you start to look for them, there's standard AC outlets all over the place where you can just pull up and charge, top up at least. And you know, the pack, this 3.3 kilowatt charger, so on a 15 amp outlet, you know, it'll fully charge this pack in a couple of hours. So you know, if I pull in and have something to eat somewhere or whatever, I'm almost fully charged before I go, or at least, you know, half charged if I'm almost flat. Also makes it a bit easier for me at home as well. I don't want to put in an EV charger just yet at home, which communicates via the CAN bus, so I can have either, you know, CAN or a standard just wall outlet that I plug into. So if I go out, I can plug into a proper EV charger, or if I'm at home, I can just plug into a standard wall socket. It'll do either, which is pretty nifty. So, and you know, not too bad a price for that. I think it was about $1,000 thereabouts, a bit under for that charger. It's a TC charger. Yeah, they do all of the chargers for the Zeros and other small lightweight EVs on the market, so they're pretty good kit. Another thing that I've been working on that's finally come through, it's taken me quite a long time, is these little bus bar braces. So these little guys, I got laser cut, then I had to tap out a million small holes, which took me a very long time, and then I've got them tin coated. So they're going on the back of the PCB, and then what's happening is that the tabs for the batteries are coming through. There's 2 slots in the PCB, so you can see these little cutouts here on there. So the tab comes through, a PCB on either side, up through, then I'll fold the tab over the top of the PCB, and then the bus bar will go over the top, and basically 2 bolts will go through the bus bar and effectively clamp the tabs between the PCB and this on the back, strengthening, stiffening the whole arrangement. This is 3mm steel, and I'll get a good mechanical clamp on that tab, and I may end up like TIG spot welding the tabs together on the front. I'll just have a look and see how it looks. I'll maybe do some like current draw tests and see whether I get any heating with just the mechanical arrangement on the top. Pretty certain that it'll be okay. I've got this little tiny cutout in there, so I can either put a dab of solder or a dab of hot glue in there just to hold it on the back of the PCB in place while I put the screws through there, so I don't lose these little bits down in behind the PCB arrangement when I'm putting the top bus bars on. So yeah, that's pretty exciting. That took me a really long time to do. There is a lot of these brackets here. There's about 300 of these little guys, slightly different shapes depending on which paired PCB I'm doing. Obviously 2 holes for each. Even using your power tap, that took quite a long time to tap those out to use them on the back. So, but they come up really nice. They're coated in tin, so we're not going to get any kind of weird dielectric stuff going on in there while we're waiting there. So yeah, so that's really exciting. So massive step forward. That's a pretty big deal as far as getting closer to the finish is concerned. So I think some of the kind of major steps now for me is to get these PCBs made. I've got to save up a little bit for those. Just yet, they're pretty expensive to manufacture because of the size of them, and to get at least the first of the packs partially assembled, and then start to be able to wire in the harness for the BMS at the same time, because that's integrated into the battery pack as a part of it. I've done all the design work for the PCB. That took me a really long time. I've got a great deal of respect for people who do electronics and PCB design. Yeah, it's a lot of work to get your head around that. And then I've got my TIG welder died. It was unrepairable. I couldn't get the electronic board for it, so I've got another TIG welder coming, again due to supply chain stuff. It's late by nearly 10 weeks now, so yeah, so don't know when that's going to come. So yeah, I'm kind of a little bit stalled. It's a bit frustrating, but yeah, overall though we are making some progress. A big amount of progress on the spatial stuff within the bike, which is really good. It's really bad because I don't have enough room, but it's really good because I can start to wrap my head around what some of my constraints are in real life. The water cooling is a significant challenge on that motor. So coming at it again, some of my wise lessons would probably be try and go air cooling on your motor. I know there's a performance drop, but it's probably less headache. Jigger and the other guys use oil cooling, and then they cool the gearbox and cool the battery pack. But they've got significant pedigree in building EVs. So I'm not comparing myself to those guys at all. But yeah, or perhaps maybe a different chassis, like a big Ducati or you know, something big, like a big old Yamaha or one of those bigger bikes that has kind of more space in the center of the chassis. This little Suzuki is a beautiful, tiny, nimble bike, but probably, looking in hindsight, probably not the right bike. I mean, I've used it because I had the chassis. So I got a hold of one for next to nothing. So, you know, and I got the titles to it. So yeah, you know, I guess hindsight's 2020, but sometimes you use what you have. So, you know, I guess there's kind of pros and cons. Yeah, so this is still unresolved. I may end up getting 2 of these. I don't know just yet. So watch this space. I'll keep you guys updated. You know, there is some issues down here around clearances as well. So at the moment, this charger is actually going to foul the chain. So I've actually got to move it up, you know, at least another, you know, in the old measurement, 2 inches or 50 mil, to clear the chain, because the chain comes straight through, you know, straight through about where that kind of foam is there. So I want to give that decent clearance, because, you know, the chain will move up and down. You get a little bit of chain slap, so you need a little bit of clearance, and we don't want you know, a chain kind of rubbing on the bottom of here, because this is jam packed full of electronics. You know, and that'll compromise the water rating or IP rating of this charger enclosure. I might think about maybe off-board charger, but that's kind of a bit naff. I just really want to be able to ride the bike around anywhere and plug it in if I need to, and, you know, just ride home and plug it in. I don't want to have to kind of fiddle around with, you know, taking a charger in a backpack or on the back or whatever, and if I go out far, or maybe that's an irrelevant point. Maybe you know, maybe the bike will just go to work and to home, and maybe on the odd ride, and just have to watch my range and throw the charger in the bag. I mean, that's kind of the zero mentality. You know, they're just like, if you go for a long ride, put your charger on the back. We've got this little nifty backpack. So, you know, that's not totally insane. So, and that would be kind of great, because it'd give me all of this space back. It complicates the electronics, because this harness here is you know, pretty chunky, and that, you know, plugging and unplugging that harness all the time in and out temporarily is not great. There's about 6 or 8 wires down in here. You know, it's a bit hard to see, but 6 or 8 cables that I'll be connecting on and off, on and off, on and off, and there's more room for failure. So anyway, that's me just yammering on for 20 minutes. So yeah, look guys, I'll keep you updated, but basically we're starting to get there now. So, and it's really exciting. Probably the next vid will be actually putting some batteries in this, or at least one piece of it. I'm actually pretty terrified about doing that. You know, we're talking big currents. We're talking, you know, bus bars that are pretty darn close together, and tabs that are poking out, and lots of room for things that could go wrong. So yeah, so I'm gonna have to be really careful about how we do this together, and I'll probably create like a bit of a procedure and kind of rehearse it a few times to make sure that we get it right. You know, I'm sure there's people out there like, oh man, it's only batteries, don't worry about it. But, you know, I've invested pretty, you know, large amount of time and effort getting these batteries and cash. I want to look after them. I don't want to kill myself. I don't want to burn the place down with a lithium fire. You know, there's a whole bunch of things there that I don't want to do. Yeah, I think it's probably worth just spending a little bit more time just checking in and making sure that, you know, I haven't overlooked anything along the way. So anyway, guys, that's it for today. I'll keep you posted, keep you updated. Yeah, it's getting to a bit more exciting time now, because we might actually start to be able to integrate some of these systems together. and you know, get a bit of more momentum away from kind of foam mock-up stage. So yeah, I'll keep you posted. Thanks for joining me. Bye.